Hello everyone, this is Arvind Seshadri from Roll-to-Roll Technologies. Today we're going to look a little bit more about some of the other functionalities on the home screen or the operator interface screen, and specifically related to actuators. So what we have today is our SCU6x controller, and this is SCU6x MD, and we have one sensor connected to it. And then in the motor port, we have an actuator connected to it right there. SCU6x MD, and there is another option, SCU6x MXD. Both of these options are allowing us to connect different thrust actuators. For example, this particular one, SCU6x MD, has the low thrust option where we have an actuator that can drive up to about 300 pound force of thrust. Anything related to intermediate web guiding, this will be the actuator for that. And this particular actuator can draw up to 4 amps of current. When we go to a higher thrust, the part number is going to be a little bit different. It's going to be SCU6x MXD, where the X relates to the extra oomph that we need. And that particular one can drive up to about 500 pounds of thrust. So a shifting stand with the total weight of no more than about 5,000 pounds can be driven with that actuator. The only difference would be the connector here would be a little bit different on this side. It'll be a high thrust, high current connector. And then for that particular actuator, we would also need a different power input. The dual rail power input will have 7 amps, up to 7 amps for that. We also can do up to 48 volts DC. Everything that the operator needs to do on a day-to-day basis can be done from the home screen. For example, things like putting the web guide in automatic or manual, jogging the web guide back and forth, and then putting the web guide in the Servo center mode. The first and foremost thing with regard to the actuator is this actuator position bar. This bar is going to indicate the position of the actuator. And this position is the electronic position that is being read by our driver. Right now, the actuator is in the middle. As we jog the web guide, you should see that actuator position to be changing. And then there's also a visual indication of when the actuator is getting near to its extreme position, and that's indicated by this yellow bar. And then if you keep moving, it turns red, which means that there's really not much left in the actuator position. So this is indicating that it's reaching its stroke limit. Now, in terms of the stroke of the actuator, these are all electronic limits that we have in the controller. In subsequent videos, we will talk about how one can change those limits based on what the actual actuator stroke is and things like that. Okay. So this is the jog. If I press this one, you should be able to see that go jog left, and it'll do the same thing. If it goes to a certain position where it's getting closer to its extreme, it's going to be yellow. We keep going. Going to get red, and then if it's off the screen, even if the actuator presses this button, nothing happens, and that's because the actuator has reached this limit there, so it will not move in that direction. However, it will move in the other direction. So that's the actuator position bar, and then we saw the jog left and jog right command there. Now, if you want to put the web guide in Servo Center, basically means different things for different types of web guides. But essentially, putting the web guide in a neutral position so that it has enough stroke to go on either side of its Servo Center position, then you can press this button. And this button, it's a single press button. And when you press that, it will bring the web guide or the actuator to its home position, or what we call as the 0 position. So one difference between the jog buttons and the Servo Center buttons are that these jog buttons are what we call as momentary buttons. That means that you need to keep pressing there for the actuator to keep jogging. As soon as you let go, the actuator is going to stop jogging. And likewise, both of them are like that. Servo center is more like a push button, and it will actually tell you the state in which it is there. For example, if I jog it, and then if I put it to servo center, this is in the servo centric state, so it's going to be green. And until the servo center operation is done, it will stay green. And once the operation is done, it will turn back to red. So there's no need for us to keep pressing that button. It's a one-time push button kind of thing. So okay, just to give you this again, when you press the servo center, it's going to bring the actuator to its home position. Once the operation is done, once it reaches the home position, it's going to turn back to red again. There are different ways in which we could do the servo centering operation, which will be handled in a future video. Essentially, depending upon whether we are just using an electronic limit or if we are using a physical proximity sensor to do that. So those are for the jog left, jog and servo center. One other thing that we have is basically this actuator position bar. If you press that motor icon on the home screen, this lets you see a bigger view of the actuator position. In this case, if the web guide moves back and forth, you can see that actuator bar will move back and forth. One thing to note about this servo center button is that this has a different functionality than what it is in the home screen. So we recommend that you take a look at the subsequent videos about this functionality before using this. So one other option that we have is that if the operators are not allowed to change the servo center position, then in that scenario, the controller can be locked in such a way that the operator cannot change that servo center position. Then if you click on this motor icon now, it'll only show you the jog length and the jog button, and it won't show you that reset servo center button. So the operators can just view the actuator position and not be able to reset the servo center position. So that's the difference between having that enabled and disabled. This is about moving the actuator manually to facilitate loading and unloading the roll. But the real thing with our system is basically it does guide the web automatically to its desired. Okay, this is about moving the actuator manually to facilitate loading and unloading the roll. But the real thing with our system is basically it does guide the web automatically to its desired position. So just to show you that, let me present the web, put the web guide in automatic mode. So as we remember that the gray bar in the middle is basically our guide point. And if we are on one side of the guide point, the actuator is going to move one way. If we are on the other side of the guide point, the actuator is going to move the other way. And that's how it's guiding the web. And then the actuator position bar indicates what the stroke of the actuator is. And obviously, once it reaches its stroke, it doesn't matter how much error we have. The actuator is not going to move in that direction. But if the error is fly on that direction, then the actuator is going to move and move back and forth like that. So this is the automatic feature of our web guiding system. And right now I'm using a single edge to guide the material. And it doesn't matter if I have one edge or two edges, it will do the same thing. So one other feature that we have is that we have an automatic web detect signal. In a previous video, we talked about this, which is that web detect signal. We can use that information to stop the actuator from moving, even while it's in automatic mode, if the web breaks. So just to illustrate that, I'm going to show that it's guiding the web back and forth. And you can see that actuator position, but if the web breaks and there's no web in front of it, then the actuator stays put. And this is what we call as lock on lost edge essentially a functionality that ensures that the actuator doesn't get caught to one side or the other if there is no web in the field of view of the sensor. And as soon as the web comes back, it's going to start guiding it. When there is a web break, it's going to stop and hold that position. And this is essentially for detecting the web break and then making sure to stop the actuator in its current position so that it doesn't disrupt the operation once the web is started back in. Okay, in a previous video, we looked at the guide point offset, basically how to reset the guide point. Again, that is useful when you have a wide sensor and you present the web at different locations. So just to go over that one more time here, I've got a wide sensor here and the web is positioned at some point. I'm going to go in and reset guide point, except that's there. And if I put the web guide in automatic, it's going to stay in that position. And if I need to change that guide point to a new location, when it's in manual, and we can still do that, the web is at this new location, and I'm going to do the reset guide point, except, and when I put it in auto, it's going to, the actuator is staying in position because the web is at the guide point location. And if I move the web to one side or the other, it's going to stop. It's going to guide with respect to that guide point. And that's the reset guide point. Now, there are situations where you are guiding the web, you got it at the spot, but you want to make a fine adjustment. And with the traditional sensors, there might be something like a micrometer, and an operator needs to reach in and try to adjust that screw on the micrometer to move it back and forth to do what is called as a fine guide point adjustment. So think of it like a lamination process. You got the web aligned guiding, but you want to change that guide point just a little bit. You don't want to make too much of an adjustment. And you want to do that while the web is running. And that is what we call as a fine guide point adjustment. How to do the fine guide point adjustment? Right now, the guide point offset is minus 119 millimeters. And if I want to change that just a little bit, then if I want to increase that, I can press that increases that. The web guide is not going to move until it goes away from the bed. So just to illustrate this thing, now it reached the limit for the dead band and it's continuing there. That's our fine guide point adjustment. So this allows you to be able to make very fine adjustments to the guide point. Again, the plus arrow allows you to increase that guide point, and minus arrow allows you to decrease that guide point. That's what is called as a fine guide point adjustment. And this adjustment can be done only when we are in automatic mode, and then each press of that will take 0.1 millimeters. I think that's what it looks like, 0.1 millimeters to move the guide plane. One of the reasons why we have this icon where the operators can see a bigger view of the actuator position is those scenarios where an operator is farther away from our controller and they want to make some subsequent adjustments to the position or essentially the guide point using a remote operator interface. But they want to make sure that adjusting the guide point doesn't make the actuator to reach its limit. And that's one of the reasons why we have that. Right now, the web guide is in automatic mode and the web is staying there, it's not moving. But if I move the web guide, you can see that the actuator bar changes. If this is just a bigger view of what we had in the home screen. Again, the reason why it is a bigger view is allowing the operators to see this interface from a longer distance while they're making adjustments to other parts of the machine, so that if the actuator reaches its limit, it's pretty evident and they can make adjustments to the other part of the machine so that the guide doesn't lose its stroke during guiding. This button, you can reach it either in automatic mode or in manual mode. Okay, one other feature in terms of resetting the guide point offset that we have is there are some occasions where you want to reset it to 0, and this has to be done with extreme care, and only people who know what they're doing should be able to do this. And that's because this is very powerful and changes the guide point immediately. So there might be some occasions where you want to absolutely reset the guide point to 0. The best way for us to do that is while it is in automatic, if you press the servo center button, it's going to show you that, hey, you want to reset the guide point to 0, do you want to accept it? Obviously, if I accept it, the web is at a different location, it's going to go all the way to one side. The actuator is going to go all the way one side because it's trying to correct for the web position. Again, when you're in automatic mode, if you press this servo center button, then it would allow you to reset the guide point. If I press accept, the guide point is going to be in the middle. And obviously the actuator is newly because it's trying to bring the web to its to the guide point reference. That's the way in which you could reset the guide point to 0. One other thing that happens when we put the web guide in automatic mode is that this tools icon is going to disappear. I'll do that and you can notice that. If I put it in automatic, the tools icon disappears. So essentially, when the web guide is in automatic mode, the operator cannot go in and change any parameters related to the edge sensor or contrast or anything related to the speed, the gain. None of those parameters could be changed while the web guide is in automatic. Just a safety, just so that we don't intentionally cause any harm when the web guide is in automatic mode. So that's what that one is. The only screen that the operator can navigate to is going to be this screen, and that's going to show you the actuator position in a later view. The operator cannot go into any other screen while in automatic mode. The other thing that you're going to notice when the web guide is in automatic mode is take a look at these sensors. When I put it in automatic mode, the buttons. So those buttons are disabled. Again, same idea. When you are in automatic, we don't allow the operator to change the orientation of the sensor. So they can't enable or disable the sensor. They cannot switch from one sensor to another sensor. All of these things have to be done a priori before they put it into automatic mode. And then again, reset guide point. If you put it in automatic mode, that disappears. So they won't be able to make any big adjustments to the guide point. The only exception to that is to reset that guide point to 0. That's the only thing that they can do. And that's the reason why we say that when you do a reset guide point to 0, be really careful. And do only when you need it. And that's the reason why we have that accept button. So if somebody presses that by mistake, we don't necessarily have to take that command unless the operator intentionally presses accept. If it doesn't press the accept button, then it'll go back to the previous guide point. So the next thing that we're going to look at is we showed how to do edge guiding with a sensor. Now we're going to do how to do center guiding with the sensor. So I'm going to change this orientation, sensor orientation, so that sensor 1 can detect both edges of the web, and that's what it's detecting. And as you remember from our previous video, when we do center guiding, and the reference for the web is not based on one edge, actually based on the two edges. So that's what is represented by this green bar. So if I move the center line of that web to this green bar to this guide point offset, and then put it in auto, then when that center line changes position, that's how we're going to guide it. Essentially center guide. So what is the advantage of center guiding? is that when you have width changes, you don't have to move the sensor as long as your guide point offset is in the right location. So for example, if I put another web that's wider, you can do an on-the-fly width change with one to another web width, and it will automatically guide either web in its center line position. And that's one of the biggest advantage with a center guiding solution, is that when the width changes, let's say you have some variability in your width, your web will always be presented to the center line of the machine. As long as the sensor is set up properly, then you can bring it to that center line position irrespective of the quarter inch or half an inch web width variation. So in terms of center guiding, the center position is represented by the green bar, and then the web guide is going to keep that center position by moving the actuator back and forth so that the green bar aligns with that gray guide point offset reference, essentially. So that's the main difference between edge guiding and center guiding. Again, you still have that option of web break. So if the web breaks, it will stop actuating and it will start back actuating when the web is present. And then obviously it's going to do it. It's going to stop until the web reaches its guide point reference. If the width changes, doesn't matter as long as that width is the center line. So that's center guiding with a single sensor.